All right, hello again. This is Jeff Scott of Blackhawk Technical College. I've been going over the first, hopefully, 17 chapters from our iOS 9 App Development Essentials text, and I've done the first 5 chapters, so now it's on to chapter 6, which is on Swift data types, constants, and variables. Again, stuff that we've talked about before, and ideally, this is going to be a lot of review. All right, prior to iOS 8, the language for iOS apps was Objective-C. With the advent of iOS 8, Apple introduced Swift. And although Objective-C has been around for about 40, and actually not about 40 years, I think about 30, but I'm not even sure. It's a very popular language, but Swift was designed, as it says here in the third paragraph down, to make programming easier, faster, and less prone to programmer error. All right, you can still use Objective-C, but people basically don't. Both this and the next few chapters, as it says, are intended to introduce the basics of Swift, and I'm going to keep using playgrounds. So, start talking about the Swift data types. And notice on the bottom of the page here, so I'm on the bottom of page 31, and the author talks about the fact that when you say var number equal 10, that somewhere deep down in the program someplace, this has to be converted into the binary 1010, because that's, again, all the computer understands. All right, is that big a thing? Really and truly, it is not. All right. So let's talk about data types. Again, there shouldn't be much in here you don't already know. Swift has several different integer data types. It provides support, as you can see there, for 8-bit, 16-bit, 32-bit, and 64-bit ints. All right, what's the difference? The difference is the amount of what the size is of each one. So as you can see there with the 32-bit int, it's negative 2 billion plus to positive 2 billion plus. All right. But the big thing about ints, as we know, is ints whole numbers, floating points. Swift provides 2 floating point types in the types of float and double. Double can be used to store up to a 64-bit floating point number with a precision of 15 decimal places or more. The float is the 32-bit type with a precision as low as 6 decimal places. Swift has a Boolean type that they call type bool, which will hold either true or false. It has a character type, which holds just a single character. And in many ways, to say that it holds just a single character is kind of a misnomer, because since you can use the Unicode character set, all right, you could put something like this in also. Where is it here? But if you do put something in like this, like you see in the blue on the screen, realize that \u and then in the curly brackets 0058 literally is the letter X. So in other words, you are putting in a single character. All right. Swift supports a string data type, and it has a lot of different ways that you can set it up and a lot of different things that you can do with it. And one of the big things with this is with strings, you typically use string interpolation. Now I'm actually going to grab all of this code right here, and I'm going to copy it to the clipboard. Then I'm going to get in, oops, not there, but I'm going to get in here where I've had this playground, and I'm going to add another page to the playground. So remember, it's File, New, Playground page. All right, it'll create it very shortly, and it'll allow me to change the name. All right, instead of calling it Untitled Page 2, I'm going to call this Data Type Examples. There. And there it is. Okay? And with that here, I'm going to grab everything that's there, and I'm just going to start fresh. All right. So that was the stuff that we had. So let me get back up to the top. I'm going to import, UI kit. All right. var username equal John. Var all right. So what do we have here? Well, var username equal John. Now you'll notice that when we set this up, we could have said here colon string. That would have been totally legit to say that. And in the same way, we could have come here and we could have said colon int, for example. But I'm not going to do those because what you're allowed to do in Swift is what's called type inference, which lets the system itself figure out what the data type is based on how it is being used. All right, so if we did this correctly, this should be saying message equals username here, which is in, as you can see, it's in the backslash, so that should be saying John has 25. All right. Message capacity remaining is, and I'm not sure exactly why, again, this is being cut off, although it is. John has 25. All right, so if we put all this stuff in here, now we say print message John has 25 messages. And for some reason I lost the message capacity remaining is 75. So how did we get all this stuff? All right. Var message equals backslash username. So that's going to give us John. Then the word has. Then backslash in parentheses. We're using interpolation there, which says go grab that value. So 25 messages. Message capacity remaining is, and then we're telling it to actually do a calculation in here. Max count, which was 100, minus inbox count, which is 25. So it says John has 25 messages. Max message capacity remaining is 75 messages. We can also come in if we want to. So we could have come in here where we've got all this stuff, has 25 messages. Let's see if we came in here and changed this to backslash n. Now hopefully you can see this on the bottom of the screen. Move that up a little bit. John has 25 messages, period. The backslash n said give us a new line. So message capacity remaining is 75. All right. And backslash n for new line and backslash t for horizontal tab are the ones you'll use most often, just like you have in other languages. All right. All right, let's talk a little bit about variables. You know what a variable is. Variables in Swift must start with the word var. A variable is a memory location that's reserved for storing some kind of data. Each variable is given a name by the programmer and assigned a value. The name assigned by the programmer is then used by Swift code to access the value in the variable. Constants, whereas variables start with var, constants start with the word let. You know that a constant is similar to a variable. In fact, some books will say a constant is a special type of variable that once a value has been assigned to it cannot be changed. Constants are useful if you've got values that are used repeatedly in your code. For instance, what if you had something like a tax rate that was going to be 35 throughout the entire program? Then you could set tax rate with a let statement to 0.35, and then it would be 35%. Unlike other languages, typically in this language, in Swift, you do not make constants, put constants in uppercase letters. But you'll notice here, that's a variable. If I changed it from John to Jeff, all right, you'll notice now that it'll come down here, and eventually it'll say Jeff has 25 messages. Okay, well, at least it should. Now, we used var for our variable names, and we use let for that constant. That's the maximum number of messages we can have. Apple recommends that when in doubt, use constants rather than variables whenever possible. Now, one big thing about Swift is a type-safe programming language. This means that once a data type has been identified, you can't change it or you'll get a compilation error. I've shown you both ways to set this up. Again, we could say var username equal Jeff like this, which is known as type inference. And the other way is to use what's called type annotation, which would look like this. Either way works, but the recommendation is that you use it, you put it in without the annotation. You let the system figure it out and infer what's going on. All right? Swift also has a type of variable that's called a tuple. The tuple is one of the most powerful features of the Swift programming language because it's like an array, but it allows you to combine or group together values of different types. So for instance, if I come down here, as they show in the book, on the bottom of page 34, and I say let my tuple equal, and I put this in parens here, 10, let's put in pi, 3.14159. My name is Jeff. All right, I don't get any error messages. Now, the elements that are in this tuple can be accessed using different types of techniques. For instance, I can say this. I can say let my string equal my tuple dot 2. You'll notice when I said the dot, it knows there's three elements, element 0, element 1, and element 2. All right? So now if I say print my string, all right, what's going to print then here? Well, eventually, like I said, this is working slow. There it is. My name is Jeff. All right, and if I wanted to be a little bit more in here, I could have even said the value of my string is and that should work too. What's the difference? Now, the difference is it should come back and say the value of my string is my name is Jeff. Let's put a couple backslash n's in there so it's a little easier for us to read. And you'll notice that once we get in here, that's exactly what it's going to say. I can grab all of the values in a tuple and assign them in a single statement too. All right? So there's different ways that this can be done. So on the middle of page 35, the author says, alternatively, all of the values in a tuple may be extracted and assigned to variables or constants in a single statement. So I can come in here and say, let my int, my float, my string equals my tuple. All right, then if I want to, I can print, and I'm going to get an error there because I've already set up my string over here. So let me just comment that out. All right, that should get rid of that error there. Oh, it's because I'll have to comment that one out too. There we go. All right, so now I should be able to come in and print what? The value of my int is my int. So let's put a backslash n at the end. Print the value of my float is, and we'll put in there my float. And then finally, the value of my string is all right, and hopefully I don't have any mistakes in here now. So hopefully down here, what's going to print out is the value of my int is 10. The value of my float is 3.14159. Oh, I have an extra there. And the value of my string is my name is Jeff. And there you see them. Okay. You can also ignore selected characters from a tuple by using an underscore as a placeholder. And you can assign names when you do this. So when we did this, all right, we could come over here and we can say, let my tuple 2 equal count 10 length message all right, then I can print, for example, my tuple 2 dot, and notice it, the IntelliSense kicks in again, message, and that should eventually print in there that my name is Jeffrey. All right. Now that stuff really should all make sense. I would strongly suggest, with what we're going to go over now on page 35, 36, 37, 38, and 39, which will end the chapter, that you take some time and really, really take a look at this, because this is stuff we've talked about, but I've talked more at it and around it than I have about it. So we're going to talk about it right now, and that is the Swift optional data type. So since we've been doing this, let's come in here and let's add another page. So we've got a page for our UI kit examples. All right, we've got a page for our data type examples. Let's create yet another page in here. So a file, new, playground page. When it comes up, I'm going to call it optional type example. Examples, I guess. So I can get rid of all this stuff. Again, I'm going to import UI kit. And I didn't change the name, but I'll change it right now. So again, I'm going to call this optional type examples. Okay, let's get rid of all the stuff we've got in there. And again, we'll remove it all and we'll import, boy oh boy, UI kit. So it says the Swift optional type is a new concept that does not exist in most other programming languages. The purpose of the optional type is to provide a safe and consistent approach to handling situations where a variable or a constant may or may not have a value assigned to it. All right. Variables are declared as being optional by placing a question mark after the type declaration. So they show an example, but I'm going to see if I can do something in here that actually is an error. So I'm going to say var index colon int, and I'm going to hit enter. All right. And I guess it's letting me do that. But you know as well as I do, if I try to print the value of index, so if I try to print index, I should get an error message here. It has not been given a value. All right. So notice what it says here. Variable indexed used before it was initialized. All right. But if I come through here and I change this to int question mark, all right, now my error goes away. Now what it probably will eventually print is nil, and it does. But what this has done is in line 3 now, it says the variable index now can either have an integer assigned to it or have nothing assigned to it. So since there isn't anything yet, it has the value of nil. So I can come down here and now give it a value, index equal 3. And now what should print down here eventually is 3. And there it is, optional 3. If an optional has a value assigned to it, the value is said to be wrapped within the optional. The value wrapped in an optional may be accessed using what's referred to as forced unwrapping. So let's look at the example. This is taken right from the text on page 35. So we've got our var index here, index equal 3 here. All right, so I'm going to remove this print statement, and I'm going to say if index does not equal nil, print, whoops, and I guess I'm missing something here. I forgot to put that in, so I'll get an error, but don't worry about it. We'll fix it. Var tree array equals oak, pine, yew, birch. All right, so we want to print here tree array index like this. Else print index does not contain a value. Again, I'm taking this right from your textbook on pages 35 and 36. This code uses an optional variable to hold the index into an array of strings, representing the name of tree types. If the index optional variable has a value assigned to it, the tree at that name should come out. Otherwise, it should say index does not contain a value. Now look at this. This is 0, 1, 2, 3. Since we said index was equal to 3, it's not nil, so we print the value there, which is birch. Had the index not been unwrapped, in other words, if we had left the exclamation point out, we would have probably gotten some kind of an error right here that said something along the lines of value of optional type int not unwrapped. All right, and there's other ways that you can get around doing this also. They mention on the bottom of page 35, you can use a let or a var in there also. So there's different ways that this can be done. All right. And again, there's several examples in the book. I'm not going to go through all of them. That's not my intention right here. We'll talk about these in class. Again, my goal is in the first week of class to go over all these chapters that I'm doing these initial lectures on 1 through 17. And if you've got questions, you can go back, and because we're going to be kind of blasting through them in class. All right. Bottom of page 37, type casting and type checking. Okay. When writing Swift code, situations will occur where the compiler is unable to identify the specific type of a value. This is often the case when a value of ambiguous or unexpected type is returned from a method or a function call. You can let the compiler know exactly what it's expecting by using what's called casting. So they've got an example on page 37 in the text, so which says 61 up here, but let me just show you that example. Oops. Right there. And as the author mentions right underneath this, there's actually two types of casting. One referred to upcasting, where an object of one class is cast to one of its superclasses. Upcasting is performed using the as keyword, and it's also referred to as a guaranteed conversion. Okay? And they give an example of that in the book on the next page here. Where they cast a UI button to a UI control using the as. On the other hand, when you downcast, as mentioned there about halfway down on page 38, it involves converting from one class to one of its subclasses. All right? And that's with the as exclamation point keyword syntax. It's a forced conversion, and that's what they're showing right here. All right? So this chapter was just designed to start getting you to think about the different data types that are available in the language. By no means is this an extensive chapter that has everything in the world in it. Again, the idea is to just get you started. All right, so we're going to come back in just a couple minutes and start going over chapter 7, which are on operators and expressions.